Hello everyone. Today we are going to solve the previous year questions of chapter AC circuits. Today we are going to solve the numericals asked in the Nagpur University exams. So let's start with some easy questions which were asked in the university exam. So here is the first question. Find the reactance of a capacitor of capacity 1 microfarad at 1 kilohertz frequency. So first of all, write the given data. So what is given? It is given that capacitance is equals to 1 microfarad. Also, it is given that frequency is equals to 1 kilohertz. Now here, what we are going to do? We are going to convert this microfarad into farad because it is a standard form. So 1 microfarad is equals to 1 into 10 to the power minus 6 farad. Similarly, 1 kilohertz is equals to 1000 hertz, which we can also write it as 1 into 10 to the power 3 hertz. So this was our given data. Now what we are going to find the reactance. So therefore reactance is equals to, we write reactance as Xc. This is the symbol of reactance. Its formula is given by 1 upon 2 pi into Fc, where F is the frequency and C is the capacitance. So let's substitute all these values. 1 upon 2 into, here pi is 3.14. 3.14, it is the value of pi, into frequency is 10 to the power 3 hertz. Okay, 1 into 10 to the power 3 is basically 10 to the power 3 hertz. Also, capacitance is 1 into 10 to the power minus 6. Wait a minute. Okay. So this, we have substituted the given values. Now after solving, we get the reactance. That is X to the base C is equals to 159 ohm. Remember that the unit of reactance is ohm. So here I am writing one note. Unit of reactance is ohms. Okay, so this was the question asked for 1 marks at winter 17 and also at summer 17 exam. Next problem is that an alternating EMF of 10 volt and 100 hertz is applied to a 5 Henry choke coil of resistance 200 ohm. Find the power factor of the coil. So first of all, we will write the given data. So what is given? We are going to write it down. First of all, it is given that alternating EMF, that is EMF is equals to 10 volt. Okay, then frequency is given as 100 hertz. Small f is equals to 100 hertz. Then is applied to a 5 Henry choke coil, which means that inductance is given as 5 Henry. Remember that Henry is the SI unit of inductance. Okay, then resistance of 200 ohm, that is value of resistance is 200 ohm. So this was our given data. So what we are going to find is find the power factor of the coil. So here I am writing the formula of power factor. Power factor is nothing but cos phi, that is resistance upon impedance. Resistance upon impedance. So this was the formula of power factor, that is cos phi is equals to resistance upon impedance. Now as you can see from the question, an alternating EMF of 10 volt and 100 Hz is applied to a 5 Henry choke coil of resistance 200 ohm. So here we can clearly see that this is an LR circuit, which means inductance is given as well as resistance is given. No capacitance is given here. So we are considering that this is the LR circuit. So I am writing here the given circuit is LR circuit. Now we know that for LR circuit we are going to find the value of impedance. So that is impedance is equals to and one more thing, impedance is denoted by capital Z, and its formula is under root R square plus omega square L square. So this is the formula of impedance. Remember this formula, it is very important formula, R square plus omega square times L square. Now you might be wondering, what is the omega? So omega is basically a angular frequency. In our question we have given frequency, but in this formula there is the value omega, that is angular frequency. Now remember that the value of omega, here I am writing, we write omega as 2 pi f. This is the formula of angular frequency, where omega is angular frequency. And see, from the given data we have given small f, that is frequency 100 Hz. So we can directly substitute this value. So now let's proceed. So here I am writing impedance Z is equals to, now substitute the value, capital R is, that is resistance is 200 whole square plus, what is the value of omega, is 2 pi f. So here I am writing 2 pi f. I will later substitute the value of f square, and what is the value of L? Inductance is given as 5 Henry, L square. So here into 5 square. So therefore Z is equals to under root 200 square plus 2. Now here see, you can substitute the value of pi, that is 3.14, and the value of f is given as 100 Hz. So here I can write into 100 whole square into 5 square. This is whole under root. Now after doing calculations on your scientific calculator, you will get the value Z is equals to 3146.36 ohm. Remember that Z is impedance and the SI unit of impedance is ohm. Also the SI unit of reactance is ohm. So here I am writing the note. Please remember these notes, these are very important. Okay, if you don't write the unit, marks might get deducted. Okay, so SI unit of impedance, SI unit of impedance is ohm. Also SI unit of reactance is also ohm. So don't get confused here. Okay, so we have find the value of Z, that is impedance 3146.36 ohm. Now I have written here the power factor is equals to cos phi, which we are asked to find, that is find the power factor of the coil. Now what we are going to do, we are going to substitute the value of impedance and resistance here. So see here I can write resistance as R and impedance as Z. So we can basically substitute the value of R and Z in the power factor equation. So therefore power factor is equals to R upon Z. R is 200 from the given data, okay, 200 ohm, and impedance is 3146.36. So after doing the calculation, you will get the answer. Therefore, power factor is equals to 0.0635. So this will be your final answer. And remember that here power factor is unitless quantity. You might ask why. So here I can write this resistance as 200 ohm. Okay, and here I have written that SI unit of impedance is also ohm. So ohm gets cancelled out. So basically the power factor is a unitless quantity. Now let's move to the further question number 3. Remember that these are all the previous year questions which were asked in the RTM Nagpur University from summer 16 to up to winter 19. Okay. So here answer. So let's read the question first. If inductance, that is L, is equals to 0.5 Henry, resistance 500 ohm, capacitance 1 microfarad. So here what you have to note that inductance, resistance and capacitance values are given, which means that this is an LCR circuit, are connected in series to an alternating EMF 10 sine 2000 pi t. Okay, find the impedance. So here we are also asked to find the impedance, but remember that here the formula of impedance will be different as compared to the previous question we solved, because in previous question we were given only with LR circuit. Here in question number 3 we are given with LCR circuit. So let's find out the answer. First of all, write out the given data. What is given? Inductance is given 0.5 Henry. Henry is a standard quantity. Okay. Resistance is given as 500 ohm. Okay. And capacitance is given as 1 microfarad. See here, capacitance is given in microfarad. So what we will do, we will convert it to farad. That is standard quantity. 1 into 10 to the power minus 6 farad. Now alternating EMF is also given. So here I am writing alternating EMF. It is given as 10 sine 2000 pi t. Now we are going to compare this value alternating EMF with E naught sine omega t, because that is the standard value of EMF. Okay. So here I am writing on comparing with E naught sine omega t, we get this is the standard value of EMF, that is E naught sine omega t. E naught is the amplitude, omega is the angular frequency, t is the time. Okay, so on comparison we get value of omega. Here E naught is equals to 10, also omega is equals to 2000 pi. Remember that it is 2000 pi, not only 2000, because the standard formula is E naught sine omega into t. So we are given sine 2000 pi. Okay, so sine omega, value of omega is 2000 pi. Now as I have told you, the given circuit is LCR because the values of L, R and C are given. So here I am writing the given circuit The given circuit is LCR circuit. Now we know that for LCR circuit, impedance, which we are asked to find, impedance, which is denoted by capital Z. Formula is under root R square plus omega L minus 1 upon omega C whole square, and this under root. Okay, so don't get confused. Formula of impedance is different from LCR circuit and it's different for LR circuit. Now we are going to substitute the values here. So therefore Z is equals to, so from our given data, value of R is 500 ohm. So this is under root, okay, 500 square plus, see here we have find out the omega by comparing with standard EMF value. So value of omega find out to be 2000 pi into, what is the value of L? It is given as 0.5 Henry. It is 0.5. Bracket should not be here. 0.5. Wait a minute. 0.5. Now here it is a minus sign. Minus 1 upon, again we are going to write the value 2000 pi into, now value of capacitance is given 1 microfarad. So 1 into 10 to the power minus 6. Okay. And bracket close to the whole square. And this is under root. Now we are going to solve this calculation. First of all, we are going to substitute the value of pi, that is 3 into 1.4, standard value of pi. So I am writing therefore impedance Z is equals to under root. See here I am including one extra step so you can better understand that we are substituting the value of pi as 3.14 plus, in exam you can directly write. So here 2000 into 3.14 into 0.5 minus sign 1 upon 2000 into 3.14 into 1 into 10 to the power minus 6, and this whole bracket square, and this is all under root. Here you can see that first your first intention might be that you can directly cancel out 2000 into 3.14, but that's not the case, because here see there is a minus sign given. So we are going to calculate this value using the scientific calculator. So don't forget to take scientific calculator with you in the exam hall. Okay, scientific calculator is allowed in the exam hall to use. So after solving, we get impedance value, that is Z is equals to impedance. Remember that these are all lengthy calculations, so you might not able to solve it on your simple calculator. You will require a scientific calculator to solve this equation. So after solving out, your impedance value is find out to be 502.97 ohm. At your home, please try to calculate these values and see if the value is correct. It should come as 502.97 ohm. So this is the value of impedance Z after calculation. Now let's move towards the next question. Question number 4. Read the question first. In a series resonance circuit, inductance is equals to 1 millihenry. Okay, C is equals to 10 microfarad and R is equals to 10 ohm. Calculate the resonant frequency. Now here you can see that after reading the question, we can conclude that the given question is related to LCR circuit because the values of L, C and R are given in the question. So first of all, our first step will always be writing the given data. So what is given? L is equals to 1 millihenry. So here it is not given in standard form. We will write into the standard form. Millihenry, that is 10 to the power minus 3 Henry. Capacitance is also given 10 microfarad. Here we can write 10 into 10 to the power minus 6 farad, standard value. And resistance is given as 10 ohm. Now here we have concluded that this is our LCR circuit. So here I can write now the resonant frequency in series LCR circuit is. So now here we have asked to find the resonant frequency, which is given as small f to the base r, and its formula is given by 1 upon 2 pi under root LC. So this is the formula of resonant frequency. So now substitute the values. 1 upon 2 into pi is 3.14 under root, value of L is given here. See, 1 millihenry we have converted into standard form, that is Henry. It is 1 into 10 to the power minus 3 into, what is the value of C? Capacitance. 10 into 10 to the power minus 6. 10 into 10 to the power minus 6 farad. Okay. So now only step remaining is calculation part, which we can do after using the scientific calculator. So after calculations, you will get the answer 1592.35 Hertz. Remember that we have asked to find the resonant frequency and unit of frequency is Hertz. So here I am again writing the note. Unit of frequency is Hertz. It is given by Hz. So we have solved 4 numericals till now. Let's move forward. So now question number 5. A capacitor of 20 microfarad is connected in series with 25 ohm resistance to a peak EMF 240 volt 50 Hertz AC. Calculate first the capacitive reactance of a circuit, impedance of circuit and maximum current in the circuit. First of all, we are going to write the given data as usual. So our answer will be given. We will remember that always start with the given data. It will simplify your question. So given data is, capacitance is given that C is equals to 20 microfarad. Okay, not given in standard form. What we are going to do, convert into a standard form. 20 into 10 to the power minus 6 farad. Next data is given as resistance. R is 25 ohm. Next we have given that EMF. EMF is given as 240 volt. Next frequency is given as 50 Hertz. Okay, as we have discussed previous problem, unit of frequency is Hertz. So we can conclude that this data is given as frequency. So F is equals to 50 Hertz. Now as you have read the question, we have given with only two components, that is capacitor and resistance. So we can conclude that this is our CR circuit. Okay, so now we know that, here I am writing, we know that omega is equals to nothing but the 2 pi f, where omega is the angular frequency and f is the frequency given. Why I have written this, you will see in the further steps. So what we have asked, the capacitive reactance of circuit. So the formula of capacitive reactance, so here I am writing for first. Okay, this first question, the capacitive reactance of circuit. So here capacitive reactance, which is given by x to the base c. Its formula is 1 upon omega c. Here we have not given with angular frequency, we are given with just frequency. So we have converted to angular frequency, which is given by 1 upon, what is the value of omega? 2 pi f, and write the value, write c as it is. Okay, now we are going to substitute the values. 1 upon 2 as it is, value of pi is 3.14, frequency are given as f is equals to 50 hertz, into capacitance we have found at 20 into 10 to the power minus 6 farad. 20 into 10 to the power minus 6 farad. Okay, so now next step is just calculation. So after calculation we find the value of capacitive reactance as 159.23 ohm. As I have told you, value of capacitive reactance we have find out as 159.23 ohm, and since we are finding out the reactance, its unit should be ohm. Next we are asked the impedance of circuit. Remember that impedance SI unit is also ohm. Now here I am writing second, impedance in CR circuit. Why we are considering CR circuit? Because we are given the data with just capacitor and reactance. No inductor data is given here. So I am writing impedance in CR circuit. It is given as Z is equals to, its formula is R square plus 1 upon omega square C square. Remember students, this formula is very important. Okay, all these formulas are very important. You will be able to solve these questions only when you will know the formula of this in your exam. So here I am writing impedance Z is equals to, so here we are going to substitute the values. What is the value of R? It is 25 ohm. So therefore Z is equals to under root, value of R is 25. Okay, next 1 upon omega. See here our data is given in terms of frequency, but our formula includes angular frequency, so that is 2 pi f. So here first of all I am writing here 2 pi f whole square and then c square. Now here I am writing under root 25 square plus 1 upon 2 into 3.14, and what is the value of f? It is given as 50 whole square. Wait a minute, let me write it here, you can better see it. So therefore Z is equals to under root 25 square plus 1 upon 2 into, what is the value of pi? 3.14, and value of frequency is 50 square. And then what is the value of capacitance? We have found out 20 into 10 to the power minus 6 farad. 20 into 10 to the power minus 6 microfarad to the whole square. Okay, remember that it's C square. and this is under root n. This is upon. Okay. Now in the next step, you can directly solve using the scientific calculator. That is, impedance will be found out as impedance Z, which comes out as 161.18 ohm. This should be your answer. Please students, try to solve this using the scientific calculator at your home and check if your value comes 161.18 ohm. If not, then you might have mistaken in your scientific calculator operations. Next, we have also asked to find the maximum current in the circuit. So here I am writing number 3rd, maximum current in the circuit. Okay. Okay. So now, what is the formula of maximum current? It is given by I naught is equals to E naught upon 1 upon omega C. Omega is angular frequency and C is capacitance. E naught is the EMF value. That is, EMF is given as 240 volt. So before solving, let's simplify this equation. So therefore I naught is equals to E naught, and this omega C will go to the numerator term, that is omega times C, and here omega is nothing but the 2 pi f. So I can write it as, let me write here, is equals to E naught times 2 pi f and C as it is. C is capacitance. Now in the next step, substitute the values. I naught is equals to, what is the value of E naught? Here I am writing E naught is nothing but the EMF. C is capacitance. So don't get confused here. So EMF value is given as, see in the question, peak EMF 240 volt. So I can write E naught value as 240. 2 as it is. What is the value of pi? It's 3.14. Frequency given as 50 Hertz. Always remember, you have to check the data given. Okay, sometimes it gets mistaken. 50. And next step is capacitance. Okay, capacitance is given as, we have found at 20 into 10 to the power minus 6 farad. 20 into 10 to the power minus 6. So here we can find out that I naught is equals to, after calculation, it's 1.5072 ampere. Remember that SI unit of current is ampere. So here I am again writing a note. SI unit of current, it is nothing but ampere. Okay, so we have solved all the 3 sub questions given in single question. So we have find out the capacitive reactance of circuit XC, we have find out the impedance Z, and we have also find out the maximum current in the circuit, that is I naught. You just have to remember these formulas, then and then only you can solve this type of questions. Let's move further. Question number 6. In a series resonant LCR circuit. Okay, so here it is directly given as LCR circuit. So just write the given data. What is given? Inductance is given. L is equals to 4 Henry. No need to convert. It is already given into standard form. Capacitance is given as 1 microfarad. Here we have to convert it to farad. 1 into 10 to the power minus 6 farad. Then resistance is given as 20 ohm. What we have asked? We have asked to find the resonant frequency. So here for LCR circuit, resonant frequency it is given as f to the base r, and its formula is 1 upon 2 pi under root LC. Okay, now as we have write the formula, now it's simple. Okay, we just have to put the values. 1 upon 2 into 3.14. What is the value of L? It's 4. Okay, and the value of capacitance is, we have converted into standard form, 1 into 10 to the power minus 6. Always remember to convert the equations when given data to its standard form. This is 6. Okay, therefore resonant frequency Fr, after the calculation you will get 79.61 Hertz. This will be your final answer. So unit of frequency is Hertz. Let's move to the next question. Question number 7. An EMF of 230 RMS voltage. Okay, here RMS means root mean square voltage given at 50 Hertz, means frequency is given as 50 Hertz, is applied to a circuit containing a capacitor of 5 microfarad. So capacitor value is given in series with resistance of 1000 ohm. Calculate the impedance and power factor. So from question you can understand that our circuit is CR circuit. Okay, so that's why it is important to first clearly read the question, so we can get the idea what is going to ask in the question. Okay, let's solve. Given data. First of all, we will always write the given data. So EMF, that is electromotive force, is given as, wait a minute. Okay, there is some mistake in the question. Let me correct it. It's not 240, it's 230 volt. It's 230 volt. 230 volt RMS. Please note down the correction. Okay, so given data is EMF is 230 volt. Next, it is given as frequency. Frequency is 50 Hertz. Then resistance. Okay, wait. First capacitor is given. So capacitance is given as 5 microfarad. So it is, we have to convert it into a farad. 5 into 10 to the power minus 6 farad. Then resistance is given as 1000 ohm. 1000 ohm. Now the circuit is RC circuit. Okay, the given circuit is RC circuit. So now we have asked to find the impedance and power factor. For RC circuit, the formula of impedance, that is impedance, which is denoted by capital Z, it is under root R square plus 1 upon omega square C square. This is the formula of impedance for RC circuit. Now here F is equals to 250 Hertz, but we have given in the formula angular frequency. So just convert it into the in terms of f, that is 2 pi f. So here I am writing again, note omega is equals to 2 omega is equals to 2 pi f. So remember this formula. Now impedance Z is equals to under root r square. What is the value of r? It is given as 1000 square plus 1 upon, what is the value of omega? It's 2 pi f whole square. Then c square. What is the value of c? 5 into 10 to the power minus 6 whole square. Remember to write the square term, okay? And this is under root. Now we know the value of pi and value of f also from the given data. So we are going to substitute this value again. See here, I can always write directly, but if you write in step by step, there is less chance that you might do some mistakes. Okay, so always try to write step by step. 1 upon 2 into 3.14 into value of f is 50 whole square. Then capacitance value as it is, minus 6 whole square, and this is under root. So now after calculation you will get the value 1185.62 ohm. Please try to calculate using the scientific calculator at your home. You should get this value 1185.62 ohm. So this was our first sub question. Now what was our second sub question? We have also find the power factor. So now power factor, that is cos phi, it is given as resistance upon impedance. Resistance upon impedance. As I have told you in previous question, that is resistance unit is ohm and impedance unit is also ohm. So unit gets cancelled out. So power factor is unitless quantity. So therefore power factor, here I can write R upon Z. So what is the value of R? R is given as 1000. 1000. What is the value of Z? We just find out. It is 1185.62. So our power factor comes out to be, after calculation, power factor is equals to 0.843, and it is a unitless quantity. Next, move to our next question. Question number 8. A resistance of 10 ohm in series with pure inductance of 0.01 Henry. AC voltage of 210 volts, that is RMS voltage is given. 50 Hz is applied to this circuit. Calculate the current and the potential drop across resistance and inductance in the circuit. So let's write down the given data. What is given? Resistance is given. Resistance is 10 ohm. Next, inductance L is given as 0.01 Henry. It is in standard format, so no need to convert. Then EMF voltage. EMF voltage means we can write it as V as a symbol. It is given as 210 volts. It is RMS, that is root mean square. Then 50 Hertz. Okay, so here frequency is also given as 50 Hertz. what else? Okay, that was it. Given data. Now calculate current and the potential drop across resistance and inductance of the circuit. So here we will write that omega. Remember that you can always write if the value of f is given. Okay, so just try to write in terms of angular frequency, so it will get easy while substituting. 2 pi f. We know that omega is 2 pi f, where omega is the angular frequency. Now what we are going to find is potential drop across resistance. So we know the formula of resistance. Potential drop across resistance is resistance into current. So first of all, we have find the value of current. How can we find the value of current? We know that current is equals to, current I is nothing but the voltage upon resistance. Okay, from where it come? It came from the Ohm's law. So voltage is given as EMF 210 and resistance is given as 10. So it will be 21 ampere. So potential drop across resistance. Potential drop is nothing but a change in voltage. So here I am writing first part, potential drop across resistance. It is formula is resistance into current, which is nothing but the Ohm's law. Okay, V is equals to I. From where it is comes? Ohm's law. Ohm's law is simply states that V is equals to I. Okay, so potential drop is nothing but the change in voltage. So here we can find the potential drop across resistance is equals to resistance into current. This is extra data. This is just for your understanding. No need to write in exam. Okay, you just have to write potential drop across resistance is equals to Ri. So what is the value of R? Value of R is 10. And we have just find out the current I. It is 21. So potential drop is nothing but the 210 volts. Now we have also asked to find the inductance in the circuit. Potential drop across resistance and inductance. Okay, so we have to find in the next step potential drop across inductance. Here we have find the potential drop across resistance. Now in next step, potential drop across inductance, and its formula is given by omega L into I. Here omega is angular frequency. Angular frequency. I is current and L is inductance. So now substitute the values. What is omega? Omega is 2 pi f. We have not given the direct value of angular frequency. We have given the value of just frequency, that is 50 Hz. So we can write omega is equals to 2 pi f. So here I am writing omega as 2 pi f. We have given the value of inductance. L is equals to 0.01 Henry. 0.01. And what is the value of current? We have just find out. It's 21. So now substitute the values. 2 into, what is the value of pi? It's 3.14. Frequency is, it is given as 50 Hertz. I am writing 50 into 0.01 into 21. So after calculation, your answer will get 65.94 volts. Remember that potential drop means change in voltage. Okay, so unit of voltage is volts. So don't forget to write the SI unit in your exams. Okay, your marks will get deducted if you don't write the units. Here also we have find out the potential drop across resistance as 210 volts. I have written the symbol V. Here 65.94 volts. Let's move towards the next question. Question number 9. A capacitor of 50 microfarad and an inductance of 0.2025 Henry are connected in series. If the resistance of the circuit is negligible, find the resonant frequency. So write the given data. What is given? Capacitor. Capacitance is given. C is equals to 50 microfarad. So we will convert into farad. 50 into 10 to the power minus 6 farad. Inductance is given as Henry in standard value 0.2025 Henry. Next, okay, so this is LC circuit. In LC circuit we have find the resonant frequency. So the formula of resonant frequency it is given by F to the base R 1 upon 2 pi under root L C. Substitute the values. 1 upon 2 into 3.14. What is the value of L? Is 0.2025. Value of C is 50 into 10 to the power minus 6. This is under root. Now after calculation, you will find the value of resonant frequency as 50.04 Hertz. Okay. So this was our question number 9. So these are all the previous year questions asked in Nagpur University exam from summer 16 to winter 19. Next question. Find out the resonance frequency of series LCR of AC circuit for L is equals to 100 microhenry, R is equals to 5 ohm, C is equals to 0.02 microfarad. So this is a LCR circuit. Values of all components given. LCR components values are given. So answer. Write the given data. Always start your answer with given data. So what is given? L is given 100 microhenry. Again, this is not into a standard form. Convert into a standard form. 100 into 10 to the power minus 6 Henry. Capacitance is 0.002 microfarad. So we can write 0.002 into 10 to the power minus 6 farad. Then resistance 5 ohm. So you can see this is a LCR circuit. And we know that the formula for resonance frequency in LCR circuit. So here I can write resonance frequency of LCR series is given by FR, and its formula is 1 upon 2 pi under root LC. Now you just have to substitute the values. 1 upon value of pi is 3.14. Value of L is we have find as 100 into 10 to the power minus 6 Henry. Many times what happens that when students see the question, okay, when they read the question 100 microhenry, they only write the value of Henry as only write the value of inductance as 100. That's not correct. You have given the value in microhenry. You have to first convert it to the Henry. That is the standard format. So remember this small mistakes. Then the value of capacitance. Here also we have given in microfarad. So we have converted into the farad, that is standard value. 0.002 into 10 to the power minus 6. This is under root. So here we have find out the value of resonant frequency after calculation as 3560617 hertz. Okay, so here you can see that this value is so large to write in terms of hertz, so we can write in terms of kilohertz or megahertz. Now we know that here I can write, we know that 1 megahertz is equals to 10 to the power 6 hertz. Okay, so this frequency in terms of megahertz we can write as 356061.77 upon 1 2 3 4 5 6, that is 6 zeros I have written because 1 megahertz is equals to 10 to the power 6 hertz is equals to 0.356 megahertz. In exam, if you have written here FR is equals to 35606177.77 hertz, that is also correct. Okay, and if you have written in terms of megahertz, it will be also correct. There will be no deduction in your marks. So let's move further. So that's what we have to ask, find out the resonance frequency. So we have find out the resonance frequency. Question number 11. Calculate the reactance and impedance. Okay, what is the formula of reactance and impedance? Just we have seen, it is ohm. Both have unit ohm. So unit of reactance and impedance is ohm. Calculate the reactance and impedance of LR circuit. Here we have given the LR circuit. When an AC EMF of frequency is given 50 hertz. Inductance is given 1 by pi Henry. R is equals to 200 ohm. So let's solve it. Write the given data. So given is frequency 50 hertz. Then L is given 1 by pi Henry. Here I am not writing the value of pi is equals to 3.14 here, or you can also cancel out. Okay, as I will solve this question, you will see that this value pi will get cancelled out with some term. Then R is equals to 200 ohm. So this was our given data, and it is given that the given circuit is LR circuit. So we will mention here, for LR circuit, inductive reactance. Okay, we have asked to find the reactance and impedance. First we will find the reactance. So for LR circuit, inductive reactance, its formula is given as x to the base L, omega L. So what we can write omega? We can write omega as 2 pi f, as we have seen in previous questions also, and the value L as it is. So here see, 2 into pi, what is the value of f? Value of f is 50, and what is the value of L? It is given as 1 by pi. So from here we can directly cancel out these terms, pi and pi. Okay, if you write the value of 3.14, it is also correct. Okay, then write the remaining terms. 2 into 50. So our inductive reactance XL comes out to be 100 ohm. Unit of reactance is ohm. Now we have also asked to find the impedance. Now impedance is denoted by capital Z. Now impedance given by capital Z. So impedance and the formula of impedance for LR circuit. See here I have highlighted the given circuit is LR circuit. It is clearly mentioned in our question. So the formula is R square plus omega square L square. So this is our formula for impedance in LR circuit. Substitute the values. What is the value of R? It's 200 ohm. What is the value of omega? 2 pi f. 2 pi f whole square into what is the value of L square? 1 by pi square. 1 by pi square. So let's simplify this. Under root 200 square plus 2 into 3 point. Okay, let it be just pi. We can directly cancel it out. Instead of writing 3.14, we can directly cancel it out. Wait a minute. So if we square out this term, we will get, what we will get? 2 square is 4, pi square, and this is f square into 1 upon pi square. So here I can cancel out pi square since it is in multiplication. This under root. Under root 200 square plus, here I can write 4. What is the value of f? Wait a minute. Okay, square bracket 4. What is the value of f? Value of f is given as 50 Hertz. So it's 50 square into 1 as it is. This under root. Okay. Now if you simplify this, your answer will come out as 20,000 ohm. 20,000 ohm. This is your answer. If you solve with scientific calculator, this should be your answer. 20,000 ohm. Impedance Z is equals to 20,000 ohm, or you can simply write as 20 kilo ohm. So this is your answer. Here we have find out the both reactance, which its unit is ohm, also the impedance and its unit is ohm. Okay, you can write in either ohm or kilo ohm. So this was our question number 11. Next move further, question number 12. A resistance of 10 ohm is in series with inductance of 0.5 Henry. What capacity should be kept in series with the combination to set maximum current? The current is supplied at 50 Hertz. So write out the given data. What is given? It is given that resistance is equals to 10 ohm is in series with inductance, that is L, 0.5 Henry. Now it is in standard form, no need to convert it. So here L. Next, frequency is given. Frequency is given as 50 Hertz. So I have written all the given data. Now as you can see from the question, the resistance of 10 ohm in series with inductance 0.5 Henry. So here we can conclude that the given series is LR circuit. So given series is LR series. So here I can write the given circuit is LR circuit. So we will apply the formula which are suitable only for LR circuit. Now here what we have asked, what capacity should be kept in series with the combination to set maximum current. The current supplied is at 50 hertz. We have here asked the capacity. Okay, here we have asked to find the capacity, which means we have asked to find the capacitance. Now let C be the capacitance. Here I am writing let C be the capacitance. Or you can write it is the capacity as asked in the question. Capacity. Okay, so we have to find the C. That is, we have let some value C as our capacitance. Now we know that for maximum current, which corresponds to a resonance, we know one identity as we have studied in this unit. For maximum current, which corresponds to a resonance. Let's read the question once again. A resistance of 10 ohm is in series with inductance 0.5 Henry. What capacity should be kept in series with a combination to set maximum current? The current is supplied at 50 Hertz. So here we have given the value of frequency as 50 Hertz. Okay, so here I am writing omega as 2 pi f. Whenever value is given in terms of f, always write omega is equals to 2 pi f, because generally our formula includes this value omega, that is angular frequency. Okay, so for maximum current which corresponds to a resonance, we have formula, that is 1 upon omega c will be equals to omega L. So here you can see that this formula is correlating capacitance value with inductance value. Now here if I transfer this term over here, I can write the value as C is equals to 1 upon omega square L. From here I have just done some transformation and we have find the value of C. Now what we are going to do, we are going to substitute the value of omega as well as L. We are not given with the value of omega, we are given with the value of F, that is frequency. So once again let me explain. For maximum current which corresponds to a resonance, this is the condition when the current will be maximum. Okay, 1 upon omega c is equals to omega L, which means the inductive reactance as well as inductive capacitance will be equal. So just I have done some rearrangement, and after doing some rearrangement I got the value of C is equals to 1 upon omega square L. I hope you have got till here. Now substitute the value of omega first, that is 2 pi f square L. 1 upon 2 into 3.14, value of f is given 50 square. And what is the value of L? It is given as 0.5 Henry. Okay, now it's a just simple calculation. So after calculation you will get C is equals to 20.2 into 10 to the power minus 6 farad, or you can write it as 20.2 microfarad. So this will be our what capacity. So at this capacity we should keep in series with the combination to set maximum current. So the value of C is found out to be 20.2 into 10 to the power minus 6 farad, or 20.2 into 20.2 microfarad. Next question. An electric lamp marked 100 volts DC consumes a current of 10 ampere. It is connected to a 200 volts 50 cycles AC mains. Calculate the inductance of required choke. Here we have asked to find the inductance. So let's find out. So given data. First of all, write the given data. An electric lamp mark 100 volts means voltage is given 100 volts. Consumes a current I naught. Okay, current is given I naught is equals to 10 ampere. It is connected to a 200 volts 50 cycles AC means. Here E naught amplitude is given as 200 volts. Amplitude here E naught is simply EMF. Okay, so it is connected to a 200 volts 50 cycles AC means. The meaning of this term 50 cycles AC means is nothing but the frequency is given, that is frequency is equals to 50 hertz. So many times what happens is that in university exams, the person who sets the paper might trick you by giving such sentence that 50 cycles AC means. So you should be smart enough to know that 50 cycles AC means simply he is given the value of frequency, that is 50 hertz. Now after writing the given data, now here what we are going to do, we are going to find out the value of angular frequency omega. So angular frequency is nothing but 2 pi f. So whenever the only frequency is given, also try to find the value of omega, that is angular frequency, because that's what we have always given in our formula. So omega is equals to 2 into pi is 3.14, frequency f is given 50. So 2 into 50 is 100 into 3.14. So omega is equals to 314 radian per second. So here we have found out the value of omega. Now what we are going to find is resistance. See, in the question it is not given that this is LCR circuit or RC circuit or CR circuit. Okay, so we have need to find some basic terms like resistance, current. Okay, so here we are finding the value of resistance now using the Ohm's law. So here I am writing using Ohm's law. Using Ohm's law, resistance will be equals to voltage upon current. See, here voltage is given and current is also given. Okay, so voltage is 100, current is 10. So our value is 10 ohm. So here we have found out the resistance value as 10 ohm. Now to find the inductance, okay, here we have asked calculate the inductance of required choke. Now to find the inductance with our given data, we just have only one formula to find the inductance here, that is I naught E naught upon under root R square plus omega square L square. See, with the given data, okay, only this formula is suitable. That's why I have used the formula I naught is equals to E naught upon under root R square plus omega square into L square. See here, as given in question, the all components are present in this equation. Okay, see the value of I naught, it is present 10 ampere, E naught, it is present 200 volts, R value we have just find out 10 ohm, omega we have found out here 314 radian per second. Okay, and we just need to find the value of L square, that is inductance. So now just simplify this. So here I am just substituting the values. What was our current? Current was our I naught is equals to 10 ampere. So it is 10. E naught is 200. What is the value of R we just found out? 10 square. Value of omega square is 314 square. What is the value of L? we don't know. Okay, we just need to find the value of L square. Okay, now here we need to find the value of L square, but it is in denominator. So first logical step should be that we should take this value of inductance to the numerator. So let's just take that to the numerator. So I can cross multiply it with 10. So therefore, if I cross multiply this term, this whole bracket, this under root term goes to the numerator. 10 square plus 314 whole square into L square. And at the same time, this 10 in the numerator will come in the denominator of 200 is equals to 200 by 10. 0 gets cancelled out. Okay, now our next step should be removing this under root bracket, to remove this square root bracket. So how can we remove? By squaring both the sides. So here I am writing on squaring both sides. On squaring both sides, we get. So on squaring this LHS term, this under root bracket gets cancelled out. So here we will write the remaining terms. 10 square, okay, plus 314 square into L square, and remaining term this 20 square. Now just simplify. Therefore 10 square is 100. If we know the value of 10, we can simply write out, but we don't know the value of 314 square. Okay, just let it be. So here I am writing 314 whole square into L square. And what is the value of 200? 200 square, it is 400. So now I can simply just transfer this 100 to the RHS and it will get subtracted. Therefore 314 whole square into L square is equals to 400 minus 100. So therefore 314 whole square into L square is equals to 300. Now see here, I can write this value L square as 300 upon this 314 whole square. Okay, here in LHS it is in multiplication with this L. L is nothing but the inductance which we need to find out. Okay, we will find out inductance only when we can transfer this 314 whole square to the denominator of RHS, because since it is in multiplication with L value, that is inductance. So now what we have to find out? We just need to find the inductance, but there is L square value. So now what we are going to do? We are going to take the square root on both sides. So here I am writing on taking square root on both sides. On taking square root on both sides. So after taking square root, this L square gets L, and here I can write under root 300 upon. Okay, so this cancel out, this square terms cancel out, and only remaining term will be 314. So see, we have simplified the calculation. Here there is no need to square this whole term, that is 314 whole square. Okay, it will be a big number and it will be a time wasting. Okay, so here we have taken the square root, and here L square gets L, here 300 will be under root 300, and here already 314 square present. On taking square root, one square term gets cancelled out and we will remain with 314. Now after solving with our scientific calculator, we will get the value 0.055 Henry. Remember, this H is Henry. Here I am writing this H is Henry and it is a SI unit of inductance. So here we have found the value of L with the given data. Okay, here we have not given that this is LCR circuit or CR circuit or LC circuit, whatever. Okay, we have just given the value of voltage, current, EMF voltage and frequency. Just using this data, by just using these four terms, okay, by using these four terms, we have find the value of inductance. So what we have did, first of all, we have write the omega value, that is angular frequency. This omega is nothing but the angular frequency. And how can we write in terms of F? Omega is equals to 2 pi F. Okay, so here we find the value of omega and its SI unit is radian per second. Then we use the Ohm's law to find the value of resistance. Resistance is equals to V by I, that is 100 by 10 ohm. Next, we use this very important formula, because in this formula only we have all the terms which are required to find the value of inductance by using the data given. Okay, so the formula is current is equals to this EMF value upon under root R square plus omega square into L square. We have to find out the value of L square. So what I have did here, I have substituted the values. Then next, since we have to find the value of L, okay, since we have to find this value, what we have done, we have taken this whole under root term to the numerator and this 10 to the denominator. Then in next step, we have to find the value of this L. So our next step should be to remove this square bracket. Okay, so we have written on squaring both sides. Now on squaring both sides, you might come across this whole term. Okay, 314 whole square. No need to write the whole square value. Just simply write the value of 10 square, which you can know, and 20 square. Just subtract these values. Then you will get L square is equals to 300 upon 314 whole square. But what we need to find? We just need to find the inductance. Inductance simply means L. Okay, capital L. So here I have written on taking square root on both sides. So on taking square root on both sides, this whole term becomes L is equals to under root 300, and here already square terms present, so it gets cancelled out one term, so only 314. Now you can easily simplify it, 0.55 Henry, and this is the Henry is the SI unit of inductance. So in this way we have find out the value of inductance. Now next question number 14. Find the reactance of capacitor of capacity 1 microfarad at 2 kilohertz frequency. Okay, so this is basically a 1 mark question. This is a 1 mark question. So for also 1 mark question, always write the given data. So what is given? Capacitor, capacity C is equals to 1 microfarad. Convert it into standard value, that is farad, 10 to the power minus 6 farad. Frequency is given as 2 kilohertz. We have to convert into hertz, that is 2000 hertz, or you can simply write it as 2 into 10 to the power 3 hertz. Now what we have asked? We have asked to find the reactance. For which circuit? Okay, so it is only capacitance is given. We have asked the reactance, capacitive reactance. Okay, so therefore reactance or capacitor reactance, capacitive reactance. See, here the term capacitor is given, so they might also ask find the capacitive reactance. Okay, here they have written just capacitance, they have written reactance, so we also write reactance, but this is nothing but the capacitive reactance. Okay, because the capacitor term is given and its formula is 1 upon 2 pi Fc. Write the value 2 into 3.14. F is given as 2 into 10 to the power 3 hertz and capacitance is given as 1 into 10 to the power minus 6 farad. After calculation, you will get reactance Xc x to the base c will be 79.62 ohm. So this is your final answer. This is just a 1 marks question asked in the university exam. So next question, let's move to our, I hope this is the final question. Yes, this is our final question. Question number 50. So write the given data first. In series resonant circuit, L 1 millihenry. Okay, so here inductance is given 1 millihenry. Convert into a standard form, 1 into 10 to the power minus 3 Henry. Capacitance is given as 10 microfarad. Convert into farad, 10 into 10 to the power minus 6 farad. Resistance is given 10 ohm. Calculate quality factor of the circuit. So remember that this is an LCR circuit. Value of L is given, C is given, R is given. We have asked to find the quality factor. So for resonant frequency in resonant circuit, okay, for finding the value of quality factor, here I am writing quality factor which is nothing but denoted by capital Q. Its formula is 1 upon R under root L by C. Okay, this is also 1 marks question. You have given all the terms value, okay, resistance, inductance as well as capacitance. You have just need to put these values after converting into a standard format. So therefore Q is equals to 1 upon resistance value is given 10 ohm, okay, right as it is, into 1 into 10 to the power minus 3. In this 10 into value of capacitance is 10 into 10 to the power minus 6. So after calculation you will get quality factor value as 1. Remember that quality factor is an unitless quantity. So here I am again writing some note for you. Quality factor is unitless quantity. Quality factor is a unitless quantity. So we have solved all the questions asked from summer 16 to winter 19 in RTM Nagpur University exams for B.Sc. Sem 1 Physics Paper 2 for unit number 4, that is A.C.Circuits. I hope you have understood all the questions. If you have any doubts, you can ask in the comment box. Thank you for watching.